Hello, welcome to this lesson on still on solving systems of ODE, linear ODE. Okay, so we are supposed to, given that we have the system, this is equation 1, okay, 2, and this is the third one, okay. Now you're supposed to write down the coefficient matrix, okay, this sentence here. Write the coefficient matrix and find the eigenvalues. Okay, so here we are good to go. The question didn't ask us to find the eigenvectors and probably solve it. Okay, all that we are doing is just find the coefficient matrix and find the eigenvalue. So what you do is, we said that the coefficient matrix, you just write the elements or the coefficients of the variables involved. Okay, so we go to equation 1. The coefficient for variable x1 is just 1. Okay, that's in the first row like that. For s2, there is no s2 in equation 1, so that will be 0. So let's go ahead and write it and see. So this is what you have. Okay, you can go back and see here. For x1 you have 1, for x2 you have 0, and x3 we have I squared. So you go to your first row. This is for equation 1, and this is also for equation 2, and this is for equation 3. Okay, so you can check from this and see. For equation 1 you have 1 here, you have 2, 8, I8 to the power 8, negative 3. For x1 here is supposed to be 1, x1 like that. Okay, it's supposed to be 1, not I. For x1 you have minus of that, for s2 you have this, and for s3 you have positive 1. So if you don't take care of here, you might even think that this is for x1, but no, x1 is within somewhere. So check the coefficients very well and the variable you are dealing with. So with this, how do you compute for these? You know that I to the power 2 is negative 1. Okay, so you can just transition. The transition this will take is this. I to the power 2 is that. Now I to the power 4 times something 4n is always 1. Okay, this is something you should know. Alright, for I to the power 4n is always 1. So it means that I to the power 8 can be rewritten as I to the power 4 times 2. Okay, and this is always 1. Alright, so this is equal to 1 like that. I hope you can see this. I to the power 4 is also equal to, there's an I to the power 4 here. So we said I to the power 4 times something is 1. But I to the power 4 is the same as I to the power 4 times 1. So it means I have 1. Now I to the power 16 is the same as I to the power 4 times 4. This is 1. Like that. What if the question is, what if there's no 4 times something? Always, each and every power can be simplified as 4 times something. Okay, let's say I to the power 5. Okay, let me write it well. It's supposed to be I to the power 5 like this. It's the same as I to the power 4 plus 1. And then this is the same as I to the power 4 times 1 times I to the power 1. I hope you get it. So this side will be 1, and then this will be left with I. So it means I to the power 5 is just I. Like that. So if you know these three tricks, you can use them to solve your complex questions, complex numbers questions. So these are what we have here. So you go ahead and then in the equation, wherever you see I to the power 2 here, you put negative 1. I to the power 4 is here, you put 1. You sum them, whatever you get, you put it there. I to the power 8, you said it's 1, you put it there. I to the power 16, you said it's also 1, so you put it there. So after every simplification, this one too is negative 1. So after all of them, this is what we have, like that. Okay, note that here is a 2 times something, and that is 1, and we have 2 times 1 is 2. This is negative 1, this is 1. Here is 0 because we have negative 1 plus 1, which is 0, and that is what we have. So now with this, we are supposed to find the eigenvalues of this whole matrix, and we said that it is the eigenvalues are the roots you get from the characteristic polynomial. You said the characteristic polynomial P lambda is equal to lambda cube minus trace of A, okay, lambda plus, or lambda square plus Pm of A lambda minus determinant of A. You said that trace of A is what the summation of the diagonal elements. So 1 plus 2 plus 1, which is 4. So I have lambda cube minus 4, lambda squared, and Pm is the summation of the principal and minor. So you stand on this, you cancel this, you cancel this, find the determinant of the remaining matrix, and that is what 2 minus 2 times 2, sorry, 2 times 1, which is 2, minus negative 3, which will become 2 plus 3, that will be 5. Then plus, you stand on the other side, you stand on this one, you cancel here, you cancel here, then 1 times 1 minus 0, which will be 1, so it's 5 plus 1, you get 6. Then you come again and stand on the last one, okay, the last principal, this here, and so you cancel here, 1 times 2, which is 2 minus that, and that will give us 8. Okay, I hope you are okay. So you sum all, you have 8, so minus 8, is it minus 8 plus 8 lambda, then minus the determinant of this. You can use your calculator to find, and that is I don't know, let me go ahead and check on my book here. The determinant is 4, I think it's 4. Okay, you can use, I'll link the video to how to use the calculator for these some of things that's in the determinants in the description section, so that you'll be able to know how to do that. Okay, alright, so in everything, this is what you have, and so you equate this whole thing to be equal to 0 and solve for your values of lambda 1, lambda 2, lambda 3, and in solving, this is what you get for your eigenvalues. So this is very, very simple question, right? So thank you, and don't forget to subscribe to my channel. Kindly leave a comment and like the video if it helped you. Okay, all right.